Ever get the feeling like AI is moving at a million miles an hour? Like just when you thought you understood the basics, bam! Something new pops up that changes the entire game.
Oh, absolutely. It's exhilarating and maybe a little intimidating all at once, right?
Totally. And today's deep dive is about one of those breakthroughs that's got everyone talking. NVLM.
NVLM.
Yeah, it stands for NVIDIA Vision Language Model.
Catchy, right? I've definitely seen that one popping up in the research lately. What's got you so excited about it?
Well, for starters, it's tackling a challenge that's kind of like the holy grail of AI building models that can understand both text and images, not just one or the other.
Right, right. We're talking about multimodal large language models, or MLLMs, as the cool kids call them.
MLLMs,
Yeah.
exactly. And honestly, the progress in that area has been mind-blowing. But here's the thing.
Hit me with it.
A lot of the most advanced MLLMs, the ones pushing the boundaries, have been kind of shrouded in secrecy.
Ah, yeah, I see what you mean. Kind of like a secret recipe that only a select few get to see. Frustrating for researchers, for sure.
Exactly. It's like we know these amazing tools exist, but without access to the code, the training data, even just understanding the underlying architecture, it's hard to build on that progress,
Hugely. And that's why NVLM is causing such a stir.
because it's finally giving us a peek behind the curtain.
Big time. NVLM is all about openness.
Openness. Okay, I'm intrigued. Tell me more.
So we're talking about giving researchers access to the good stuff. The model's code, the weights, even the training data itself. This kind of transparency is huge, GE.
And that's pretty rare in the world of cutting-edge AI.
Right. Almost unheard of. And that's what makes NVLM so exciting. It's like they're saying, hey, we're not just going to tell you about our cool AI. We're going to let you take it apart and see how it ticks.
Now, that's what I call collaboration. But hold on. It's not just about being open, right? I mean, NVLM has to be doing something special to get everyone so fired up.
Oh, it definitely is. In fact, one of the things that makes NVLM so fascinating is its flexibility. They've actually outlined 3 different ways of architecting the model.
Wait, back up. 3 different architectures. So it's not just one AI. It's like a whole team of them working together.
Kind of. It's this really clever approach where they've got a decoder-only model.
Decoder only. Okay, that one sounds a little, I don't know, straightforward, like following a recipe line by line.
That's a great way to put it. It processes information step by step, very methodical.
So super useful for researchers who really want to understand every single step in the AI's thought process.
Absolutely. It's like having a window into the AI's brain. But then to shake things up, they've also got a cross-attention model.
Cross-attention. Okay, now that one sounds a bit more, I don't know, free-flowing, like jazz improvisation compared to classical music.
You're getting it. It's all about understanding relationships and connections. Instead of just processing things sequentially, it can look at all the different parts of an image or text simultaneously.
Ah, so it's not just what you see, it's how it all fits together, right? The bigger picture.
Exactly. And then, to round it all off, they've got the hybrid model.
Let me guess, this one combines the best of both worlds.
Bingo. Taking the step-by-step approach of the decoder-only model and blending it with that big picture thinking of the cross-attention model.
Talk about a dynamic duo. Or I guess in this case, a dynamic trio.
Yeah.
No wonder people are excited about the flexibility this offers. It's like NVLM comes with its own built-in AI toolbox ready for anything.
Right. And that's not even the most impressive part. Where NVLM really shines is in its ability to handle images, especially high-resolution ones.
Oh, you mean those images where you can zoom in a million times and still discover new details?
Exactly. Imagine how much information is packed into one of those. For an AI, trying to analyze that all at once would be like trying to drink from a fire hose.
Information overload. I can see the problem.
So NVLM uses this really cool technique called dynamic tiling. Instead of choking on the whole image, it breaks it down into smaller, more manageable chunks or tiles.
Okay, so it's like solving a giant jigsaw puzzle, but focusing on one section at a time.
Perfect analogy. And this is huge for tasks like optical character recognition or OCR.
OCR, you mean like when your phone's camera can scan a document and turn it into text?
Exactly, that kind of thing. The research shows that by using dynamic tiling, NVLM sees a big boost in OCR accuracy compared to models that try to process the entire image in one go.
It's about working smarter, not harder, right?
Definitely. And it's not just about the quantity of data NVLM is trained on, it's about the quality. The creators were really picky about the data they use.
Picky eaters making for a high-performance AI. I like it. What kind of data are we talking about here? Pictures of cats on the internet.
Not quite. They focus on using a high-quality data set that covers a really diverse range of tasks. We're talking about everything from captioning images and answering visual questions to even solving visual math problems.
So they didn't just want NVLM to see the world, they wanted it to understand it, to reason about it.
Exactly. And that brings us to one of the most exciting aspects of NVLM, its ability to excel at both image and text-based tasks. It's something a lot of MLLMs struggle with.
Yeah, it's like, can you really call it artificial intelligence if it can only do one thing really well? The dream is to have AI that can seamlessly navigate between words and pictures, right?
Absolutely. And that's what we call production-grade multimodality. It's that sweet spot where an AI can handle both visual and linguistic tasks without breaking a sweat. But it's surprisingly tough to achieve.
Because it's almost like trying to train two separate brains at once.
In a way, yeah. A lot of MLLMs, when you push them towards multimodality, they kind of hit a wall. They might start forgetting some of their text processing abilities during all that visual training, or they just never quite master the language side of things in the first place.
So it's a balancing act.
Totally. But this is where things get really interesting with NVLM. Remember how we talked about them being picky eaters with their data? Well, it turns out part of the secret sauce here is including a huge high-quality text-T data set alongside all those images.
Wait, so instead of the images confusing the AI, it actually helped it get better at language.
It's wild, right? The research actually shows that NVLM's performance on text-based tasks actually improved after it went through all that visual training.
No way. That's like learning a new language and suddenly becoming a grammar whiz in your native tongue. How is that even possible?
It's not entirely clear yet, but there are some theories. One thought is that it has to do with the specific type E of visual data they used. Remember we were talking about those visual math problems?
Yeah, that NVLM was trained on.
Right, so it wasn't just passively looking at pictures, it was having to solve puzzles, to reason about spatial relationships, and the researchers think all that visual problem solving might have actually boosted its overall reasoning abilities, even when it comes to language.
So it's like cross-training for your brain. Fascinating stuff. So to sum it all up, we've got NVLM, open, flexible, handles high-res images like a champ, and aces those benchmarks. Where's it go from here? What's got you most excited about the future of this technology?
Honestly, for me, it's about the potential NVLM represents. It's not just about building more powerful AI, it's about building AI we can understand, that we can collaborate with. That openness, that transparency, it's crucial if we want these advancements to benefit everyone.
Absolutely. And who knows what other surprising connections we'll uncover as we continue to push the boundaries of AI. Maybe one day, AI won't just be helping us understand the world around us, but also ourselves.
Now, wouldn't that be something?
It sure would. Well, that's all the time we have for today's deep dive. If you're as intrigued by NVLM as we are, you'll find a link to the full research paper in the show notes. Until next time, keep exploring, and we'll see you on the cutting edge.